and welcome back to Chapter 22. Last time, we performed a hypothesis test over this example involving the lifespan of these batteries, and we determined that with such a high p-value, 0.2377, we failed to reject the null hypothesis and concluded that there is not evidence that the average lifespan is over 300 minutes. So essentially what they're trying to do here, create some really long-lasting batteries. We don't have conclusive evidence that they have actually done that. You may recall the sample mean was above 300 minutes, but it was so close to 300 that we weren't convinced that the mean for the entire population of batteries is above 300. So, before we move on to anything else, I want to show how you can do this on the calculator. Okay, so we went through all the calculations in that last video, calculating the t-score, all of those things. I would recommend doing it that way for the AP test, which, by the way, I just got word from a rep at the College Board. The only way to take the AP test this year will be the online version. Okay, so that'll be a 45-minute free response test. They will not be administering the traditional paper and pencil 3-hour exam that has multiple choice and free response. So you'll have to take the free response test. I'm sorry, if you were looking forward to some multiple choice, it's not going to happen this year. Sorry. So, once you write out all that stuff, you may wonder, did I do that right? And if you have some time, or if you get stuck and you just need numbers to work with, there is a way to do these t-tests on your calculator. This is a one sample t-test. We only have one variable we're looking at, the average lifespan of these batteries. So to do this, you will go to, let me see here, stat. And then you'll go over to tests. And this one is actually, on my calculator at least, it's number 2. It says t-test. So you hit enter there. And just like when we did this for proportions, for the input you'll have 2 options. It says data or stats. If you have the raw data values, you'll use data, and it'll ask you what list those numbers are in. So in our case, that list is L1. So it says input data. Mine asks for the value of mu naught. This is the value that's in the null hypothesis of your test. And for this example, that was 300. So input data, mu naught is 300. The list, for me anyway, is an L1. The frequency, for this class, you will always put 1 for the frequency. There is a way that you could input the data into the list such that the frequency would not be a number like 1, but we're not going to deal with that. Just keep the frequency 1 for these. And then it is essentially asking you, what is your alternative hypothesis? Is it that the mean is not equal to a certain number, less than a number, or greater than a number? And for this one, it was greater than. So this will be all the things you highlight or type in there, and then you will calculate. So I do that, and it gives me the value of the t-score, 0.7387. That's what we got when we did it by hand using the t-score formula. It gives the p-value, 0.2378. Well, to rounding, that's what we got doing it by hand and using TCDF. It also gives you the value of x bar and the standard deviation of x and the sample size, n. Okay? But what if you didn't have all the data values here? What if you're given an example and all you're given is the sample mean and sample standard deviation? You can still use t-test, but if you highlight stats instead of data here, it needs to know the value of mu naught, which would still be 300, and then it asks for x bar, Sx, which is the standard deviation of the data set, and n, and this. Okay? So you can still do it even if you don't have the individual values. Actually, that would make it faster. And that's why if you're given a question like this on the AP test, I think they would just give you the mean and standard deviation of the data set. Okay, and if you hit calculate there, you will get the same values for the t-score and the p-value. So that is how to do these on the calculator. All right, so we failed to reject the null hypothesis. We said there's not evidence that the average lifespan is over 300 minutes. But the sample mean was over 300. It was like 305 or something like that. So why is it that we're failing to reject the null hypothesis if the sample mean is what we want, greater than 300? We might see that a little more clearly by calculating a confidence interval. And I want to make it a 90% confidence interval. 90%. So we will need the formula here. That's going to be x bar plus or minus the critical value, t star, and I'm just reminding myself that this is with 11 degrees of freedom, times the standard error of y bar, or x bar. Sorry, we're using x here. In my notes I have y bar. Same thing. If I slip and say y bar, that's the same as x bar. It's just the sample mean of those data values. Okay. So, we know most of these things. X bar, the sample mean was 306.25. We're not sure what t star is yet. We'll figure that out in just a minute. But the standard error is what we used when we calculated the t-score. That's going to be, just going to leave that open for now. It's going to be the standard deviation of our data set. That was 29.31 divided by the square root of n. So that's 12. I swear that's a 12. There. Okay. So we've got everything except for the critical value. And the way we find that we're going to use inverse t. Inverse t. Okay? And for those of you who don't have the inverse t function in your calculator, I will put in the description down below a link to the code that you would have to put in order to get your calculator to do this. And that will work exactly like how I explained. So you may want, if you're one of those people that doesn't have this in their calculator, this function, go to the description right now, click that link, program that into your TI-84 or whatever it is you have. Pause the video while you do all that, and then when you're done, come back and you'll be able to figure this out. Okay, so we're going to use inverse t, and we want a 90% confidence interval. So what I would recommend, draw your curve there. 90% confidence interval means we want 90% of our data in the middle. That means these are each 5%. And we're looking for this t star, this value right here, where 95% of the area is to the left. So in order to find that, we're going to use inverse t of all the area to the left, as well as the degrees of freedom. If you type this into inverse t, it should give you what you need. So let me do that real quick. You go to inverse t. That's under second dister. And for me, it's number 4, inverse t. Put in 0.95, comma 11. Takes it a second to think. And it gives me 1.796. $1.796 for the value of t star. So from here, you can manipulate this by hand on your calculator, or you can use the calculator, but not in the same way. Instead of going to t-test, you can go to stat tests, and then t-interval. Your data is still an L1, the frequency is 1, and the confidence level is 0.90. Calculates. Just want to make sure here. Yeah, that's what I got before. That gives me 291.05 to 321.45. Okay, so that is our confidence interval here. So, oh boy, I don't have a lot of room to interpret this confidence interval. What I would recommend, take a second, pause the video, and interpret this confidence interval in words. See if you can do it. Okay, so what I would say is, I don't know if you're going to be able to read this. I'll just put it down here and erase it. We are 90% confident that the variable that we're interested in, the lifespan of these batteries, the true average lifespan, we are 90% confident that the true average lifespan of the batteries is between 291.05 minutes and 321.45 minutes. 90% confident that the true average lifespan of the batteries is between 291.05 minutes and 321.45 minutes. And if you think about it, what you're saying here matches what we said in the hypothesis test, right? There is not evidence that the average lifespan is over 300 minutes because we're 90% confident that it's in here. 300 is inside this interval. And to be even more specific, there are values in this interval less than 300 that we are 90% confident that it's somewhere in here. For us to be able to reject the null hypothesis, that would correspond to these values all being above 300. So the fact that we failed to reject the null and said there's not evidence of the average being over 300, this is saying the same thing. We don't have evidence that the average is over 300 because it's somewhere in here with 90% confidence. Okay? Cool. So there's just one more thing that I wanted to talk about in this video. Not too bad. We're going to keep this one pretty short today because you've got homework to do and a quiz to study for, right? Let's say we wanted to conduct another trial with these same batteries. How many batteries would we need to test to be 95% sure of estimating the mean lifespan to within 15 minutes? Or within 5 minutes? So here we did a 90% confidence interval, and we're about 15 minutes on either side. But we're asking how many batteries we'd have to look at to be 95% confident within 15 minutes. If you think about it, the number we would need to test to be 95% confident with about the same margin of error should be a bigger number. We should have to test more than just 12 to get there. And to get within 5 minutes, that should be even more batteries because you want a smaller margin of error. So, this is another margin of error problem. So, let's use the formula. Same formula we've used in the past. Except we usually use the critical value for the model we're using times the standard error, right? This is the formula we want to use. But T star, we need a number of degrees of freedom to use T star. But how many degrees of freedom are we using? Degrees of freedom is n minus 1. So we would need to know n to find this. But the problem is asking what n is. We don't know. So we actually can't use T star here. So what we're going to do instead, you have an idea? We're not going to use T star. We can use Z star as like a first draft. Okay? It's an estimate. We're going to use Z star here and the standard error to find what we need, to find n, and then we're going to use that information to do this again using T star. So let's see here. We want the margin of error for the first one to be 15 minutes, so this is 15. We need Z star for a 95% essentially confidence interval. That's going to be 1.96. And then the standard error is going to be S over the square root of n, right? And we know S already. It's the 29.31. Okay, so we have 29.31 over the square root of n. And we just need to solve this for n. So what I would recommend, pause the video for a minute, find n, and then come back. By solving this for n, I get that n is approximately 14.67. Now this is not the answer to this question, because to answer this question we have to use T star. What this allows us to do, this is going to tell us what to use for degrees of freedom when we change this to T star. So if we get 14.67, that means we're going to use how many degrees of freedom? We don't want to assume that we have more degrees of freedom than we have. And technically, degrees of freedom could be a decimal. You'll talk about that in a future stats course if you take them. Okay? We're going to round this number down. We're going to assume that we have 14 degrees of freedom. Is it that big a deal if we make it 15? Not really. But if you want to do it correctly, which is what I'd recommend, you got 14 degrees of freedom here. So, we take this, and we're going to do this formula again, but using T star with 14 degrees of freedom. Okay, so we want this to be 15. Now we need to find T star of 14 degrees of freedom for a 95% confidence interval. This is going to be the same. Okay, so here again we've got to use inverse T. But if we want a 95%, then we would have to type in inverse T of 0.975 with 14 degrees of freedom. This is going to be 2.145. Okay. If you're not sure about that, I recommend doing it on your own calculator. See where this comes from. Okay. Again, we solved this for n. Pause the video if you like. Come back when you've got it. I get 18 for this. 18. So with a sample size of 12 originally, we were able to get within about 15 on either side for a 90% confidence interval. But to have about the same margin of error, but being 95% confident, we said we'd have to sample more. Instead of 12, we'd have to sample 18. Now, you could go through this entire process again to answer this question. How many would you have to sample to get a margin of error? 5 minutes. Or you could use the idea that the margin of error is proportional to 1 over the square root of n. If you want the margin of error to decrease by a factor of 3 times, if you want your margin of error to go down by 3 times, then that means n has to do what? It has to go up, because it's in the bottom of this fraction, not by 3 times, but you're taking the square root of whatever this number is to get 3. It would have to go up by 9 times. Okay? So all you would have to do is multiply, I would multiply the decimal by 9. So 17.56 times 9. I actually haven't done this. Let me type that in real quick. 17.56 times 9. I get 158.04. So that turns into n equals 159. So in order to be 95% confident that we're within 5 minutes, we would have to sample 159 batteries. It's a lot more. Okay, so that's pretty much it for chapter 22. It was mainly hypothesis tests and confidence intervals for one sample when we're talking about finding the mean. Right? So this should be Thursday's video. So for Friday, there will not be a new video. Friday's e-learning day, your assignment is essentially the chapter 22 assignment from the textbook and doing the chapter 22 quiz on Canvas. I will send you a remind to remind you to do that. If you have questions on the homework, again, I'm available on Remind. I'm available through email. And if you need some face-to-face instruction, I'm willing to work something out. We can find a time to do that. We can do that over Skype. Okay. And then next week, I believe Monday and Tuesday are going to be waiver days that we're not going to use. So it would be technically next Wednesday that you would have the first video for chapter 23 that we'll work on. We'll do chapters 23 and 24 the next couple weeks, and then you'll be getting some review problems to work on. I'm hoping to get some information from the College Board about what the problems on the exam are going to look like so that I can assign you similar problems for review. I'm excited to see what they do with it, and don't worry, you'll be very well prepared for whatever the AP test might throw at you. All right? So, enjoy, do that homework, study for that quiz, and have a good weekend. We'll see you with a new video next week. Bye.